Hello, hello. Welcome. Welcome to Turbocharging Argo CD. My name is Justin. I'm a support engineer here at Akuity. I'm also an Argo CD maintainer. And congratulations, you all. You made it to the last talk of KubeCon. We're real excited to do this talk. This is about 2 years in the making, testing, doing POCs. So we're real glad you can make this. I know you all can be elsewhere, so thank you again for being here. I'm also an Argo CD maintainer. I've been working with the project for about 3 years now. And I'm an avid scuba diver in Southern California. I've been diving for about 26 years.
Hello, everyone. I'm Shomo. I'm also an Argo CD maintainer for the past 2.5, 3 years. I'm also a founding engineer at Akuity. And as a pastime, you'll find me hopping burger joints. So if you have any suggestions, let me know. I'll love to give them a try. OK, so that's a lot of food talk. Let's get in the talk itself. So let's talk about the agenda, what we'll be covering today. So we'll start off with a quick introduction to Argo CD. We'll talk about the architecture of Argo CD. And then we'll talk about Redis, the star of the show, or the villain, however you want to put it. And we'll talk about what Redis is in Argo CD, what it's doing, and the problems that we are faced with Redis. Once we know the problems, we obviously need to know the solution. So we'll talk about the solution Dragonfly and how it differs from Redis and what kind of performance benefits it can get you. And finally, we're going to close off with Justin showing some performance metrics and savings in general that hopefully will convince you guys to give Dragonfly a shot in your Argo CD setup. OK. Let's talk about Argo CD a bit. I'm pretty sure most of you guys here are already aware of what Argo CD is, how it works, and all of that. So I'm going to keep it very short and simple. Oh, sorry. I think we jumped. There we go. So I'm going to keep it very short. If you want to know more about Argo CD, there's a pretty good documentation online, so you can just go up there, read more about it. It'll always be much more in detail than what I'll be covering today. So in short, Argo CD is basically a GitOps-based CD tool built for Kubernetes. So what you can do is with Argo CD is like you can define your application resource manifests in Git and tell Argo CD where to deploy those resources to, like which clusters. And Argo CD will just deploy it for you and manage the live status of those resources and make sure that it matches the data that's stored on the Git repository. Let's talk a bit about the architecture itself. So most of us here are probably already used to the Argo CD web UI or the CLI. So we are used to interacting with Argo CD through the CLI, creating them, refreshing, or syncing the Argo CD apps, right? So at the top, we have the Argo CD UI layer. Then there's the application layer, which is basically just the Argo CD server, which deals with all the API application, like API calls from these user interfaces. Then we have the core layer, which is a core component of Argo CD itself. So we have the application controller, the application set controller, and the repo server. As the name suggests, the application set and application controller is responsible for reconciling the application resource and the application set resource. To keep things simple, basically, application resource is what you define to tell Argo CD where to look at for your application resource manifests and where to deploy those resource manifests, like which clusters and stuff. Whereas application set is more of a tool to dynamically generate these applications itself. So for example, if you have a multi-cluster setup and you want to deploy the same resources to different clusters, then you can have an application set dynamically generate these applications for you instead of having to manually generate the applications. Then we have the repo server, which is responsible for generating the manifest itself from the Git source. So it goes out to Git, gets all the manifest, runs the manifest generation logic, and provides the manifest to all the other core components that eventually use that. So after the core layer, we have the infra layer, which are basically the supporting components or the external components of Argo CD. It's not directly related to Argo CD as such, but those are required for Argo CD to work, right? So from the first, we have Redis. So Redis is basically the in-memory storage. We all know about that. I'll talk about Redis a bit more in the next slide, so let's just skip that for now. Let's talk about Kube API server. So Kube API server is the Kubernetes API server that deals with the CRUD operations of all the other components. So if you want, Argo CD server, the Argo CD controller, and the app set controller talk with the Kube API server to generate the resources and everything for your Kubernetes server, like API, like cluster. Then we have the Git repository where you are storing your Git resource manifests. And then finally there's Dex, which is basically for SSO and group and RBAC stuff. Now, sorry, again, it's skipping around. Okay, now that we know about the architecture, let's talk a bit more in details about Redis in Argo CD, whether it's a critical component or it's just a convenience for us, right? So as I was saying, Redis is just an in-memory store, and most applications just use Redis as a temporary store for speeding up queries and processes, right? And in short, Argo CD does the same. For Argo CD, Redis is just a disposable cache, and that means it's not a critical component. If Redis cache goes down or the Redis pods itself disappears sometime, Argo CD is going to still be able to function. Basically, it'll reconcile your applications, it'll make sure your resources are deployed and still working as they should. But there's always a but, right? So if Redis is lost or the cache is lost, there are some quality of life issues that you might face. The most visible one is probably in the UI. So you can probably try it out later. But if you, let's say, deploy an application today, that is, let's say, deploying a deployment, if you go to the application details page, you can see the application resource tree, right? So you have the application, then the deployment, then the replica set, and then the number of replica pods that you want for your application. So this view itself is not completely generated from the application resource itself or the status. Some of the data comes from the Redis cache. So if the Redis cache is lost, some of this data will be lost, and you won't be able to see all of that information. So the information that is particularly lost is basically the replica set and the pod details, which are not the direct child resources of the application itself. So if you're a heavy UI user using Argo CD UI to debug or look at logs and stuff, then it will be an inconvenience for you temporarily. As soon as the Redis cache comes back and it's resynced, all the data comes back also. The other problem you might face is general slowness in Redis in the application syncs and resyncs. So Argo CD basically caches the Redis, not the Redis, sorry, the Git manifests when it's doing a resync. And every time you do a sync or a refresh, it's going to go out to the Redis cache and look at the commit. If it matches, it'll just pull that from the cache itself. So if your cache is gone, it has to rebuild the whole manifest generation process again, which could take a minute. So yeah, that's another problem. But to conclude this discussion, I guess, I want to say that Redis is not a critical component. It's just a part of Argo CD that just helps us make it faster and more convenient for users, right? So now that we know what Redis is doing for Argo CD, let's take a look at what a normal Argo CD, again, sorry about that. There we go. So now that we know about what Redis is doing for Argo CD, let's take a look at what a normal Argo CD setup running with Redis looks like. So this is basically Argo CD HA setup. So if you're running Argo CD in production, you're probably running Argo CD Redis, Argo CD HA setup. And as you can see, by default, there's 14 pods and 20 containers. And the cache overhead, like of the total number of pods and containers deployed for Argo CD in the setup, is 6 pods and 12 containers. So that is like 6 pods and 12 containers all dedicated to Redis, which is basically a disposable cache at this point, right? And if you're wondering, it's basically 43% of all the pods and 60% of all the containers deployed for Argo CD. And that might not make sense for most of you. Like, why is disposable cache being given so much resources, right? So that's not the only problem with Redis itself. Apart from the large number of resources dedicated to the cache, we also have other problems with Redis HA in general. So Redis has a history of split brain issues. As Redis runs a HA setup, there's multiple replicas going on, but there's only a single writer replica. And the other 2 replicas, for example, are just replicating the data over. In case of a split brain, what happens is part of the data is not replicated over to the other instances. And in that situation, if there's a failover situation, your data is missing. And we have, there's a lot of work done on fixing the problems, but there's still situations where this issue pops up from time to time. The other issue is generally with scaling itself. So for Redis to scale up, you need an odd number of replicas because of the quorum requirements. And that means the minimum number of replicas for HA that you can have for Redis is 3. And if you want to go up the number, you have to go in odd numbers, so 5, 7, 9, so on. And it's also not as easy as going to the Redis the stateful set and just saying, I want 9 or 7 replicas. You have to actually make some configuration changes to Redis itself so that it works out properly with the new number of replicas. And finally, there's also management issues. So sometimes what happens is Redis, the pod gets evicted or just restarts. And in that situation, it might get stuck in initialization or startup. And it's been a pretty common problem that I have personally faced. So yeah, it's a general problem there. Given all of these problems, what is the solution, right? So you guys probably already know the solution. It's Dragonfly. So what is Dragonfly? So Dragonfly is basically a drop-in replacement for Redis. It is fully API compatible with Redis itself. So your code doesn't have to change at all. You can just remove Redis and drop in Dragonfly, and it'll just work. The other benefits of Dragonfly are its performance benefits. You can take a look at the, oh, is it not there? Sorry. There you go. The other benefit of Dragonfly is the performance benefits itself. So we have overall 25x higher throughput and 30% better memory utilization when compared to Redis itself. And it maintains sub-millisecond latencies even under heavy load. You can take a look at the Dragonfly repository and the websites for more benchmarking numbers. But the more important thing for us, at least, has been that Dragonfly comes with a Kubernetes operator itself. So this operator makes it super easy and seamless to create a Dragonfly cluster and scale it up. So we don't have to deal with the manual configuration requirements like we had in case of Redis to increase the replicas or reduce the replicas. Dragonfly controller does it for us. So given all of that information, let's take a look at the Argo CD setup with Dragonfly. So this is basically a one-to-one setup with the previous Redis version that we just saw. It gives the same guarantees of HA as the previous version. The only difference is we have removed Redis with Dragonfly pods here. And the first thing that you can already notice is the number of pods. It has reduced significantly here. We have only 10 pods and 10 containers running right now in this setup, even though it's completely HA still. The reduction in number, as you can see, so we are 4 pods down and 10 containers down from the Redis setup. And all of that is dedicated to the Dragonfly change that we have made here. In this situation, Dragonfly is running just 2 pods and 2 containers, and it's completely HA. If there's a failover, the other pod will take over, and it'll just continue to work. There's still a controller running, which is separate in a separate namespace, but that's still a single pod and 2 containers. So even if you consider all of that together, it's still a lot of savings in terms of the resources deployed. If you're interested in playing with it, there's a Git repository that you can take a look. It has the README has all the steps and documentation of how you want to run this setup. And if you want to play around with it, give it a shot, please. So I believe these numbers already should convince you enough to give Dragonfly a chance. But if you're still on the brink, then Justin is going to provide some more information on Dragonfly and the metrics itself that might just convince you.
All right. As Soumya mentioned, the number of pods and the number of container reduced. It's real important. There's 2 common patterns that Argo CD is used in enterprise systems. One is the hub and spoke, where there's one big, large central control plane, and the other is one Argo CD instance per cluster. Here at KubeCon, talking with a lot of customers, we've seen a pattern that's been really common where a lot of customers are running one Argo CD instance per cluster. There's pros, there's cons to both of those. It's probably beyond the scope of this discussion today. But I want to highlight what we found here at Akuity. We actually run hundreds of instances for customers. So our pods and container savings, our initial deployment, we deployed 8 customer instances to Dragonfly DB. And for the pods, we actually saw across their entire instance about 20% reduction in the number of pods used and 33% of the containers used. So anyone knows when you have a bunch of nodes on a cluster and you decrease the number of pods, number of containers, it increases your pod capacity and improves your cluster bin packing. Also, one thing that we noticed too, and these are all expected from moving to Dragonfly from Redis. One other thing is the metrics. You're going to have a lot less metrics to store, and along with the logs. One other thing that we expected was the CPU requests that are required and the memory requests required were also going to drop. These 8 instances, we saw. Oops, I did the same thing. Across these 8 instances, we saw around a 14% in CPU request and a 20% decrease in the memory. These instances that are up here are actually a mix. The Qt platform has an autoscaler built in where when a customer has higher demand, we automatically increase the amount of resources required. Obviously, it's just not scalable to manually have somebody go and do that manually. So this is a little bit of a mix. If we were to use the smallest instance size that we deploy across 1,000 instances, it would be about 309 CPU requests and about 1.8 terabytes of memory in just request. Switching the Dragonfly 1,000 instances would bring it down to 100 CPU and about 1 terabyte of memory. So you can see the significant savings just in the CPU request and memory as well. So these are some things that we expected. Let's talk about the surprises. So surprises. What we're going to do is we're going to talk about actually how Redis uses replication. There's typically a primary and 2 secondaries with Redis HA. And they consistently replicate data from the primary to the secondary, and the secondaries replicate from some of the other secondaries. There's a lot of data transfer here. And in the event that there's a slight network disconnect, there's a backlog configuration. And what this does is it stores the set commands or any commands that are set. So in the event there's a small blip in your network, rather than doing a full sync between the primary and the secondaries, you're able to do a partial sync. And one interesting thing that we learned about Redis does this and stores this backlog in every single primary and secondary instance. By default, Redis sets a 1 megabyte backlog. Typically, we found most customers to provide reliability. We actually had to increase this to 64 megabytes. So we're using about 192 megabytes per customer just for the backlog. Redis, it actually doesn't use megabytes. It's the length of the state replication. So basically, if you're sending 128 set commands, they could be big, they could be small. We're actually able to set this with Dragonfly, which provides our customer a little bit more stability. We don't have to dedicate specific memory for that. So what does this all mean? Here, this graph is actually pretty impressive, and this is exactly what we didn't expect. It's funny, when we give engineers tools, they do funny things with them. They take them to the absolute limits and something we didn't even expect. Argo CD has a feature called multiple sources, where you're allowed to define multiple sources in your application, whether it's a Helm chart or just plain rendered manifest. We had a customer doing something very, very interesting. They used 47 sources. And what this did was cause Redis to go absolutely crazy. Anytime there was a change in any one of those sources, it would have to send the set command to Redis. We actually found these keys to be about 20 megabytes each, which were massive. And whenever that got synced to the primary instance, it had to get synced to the secondary. Any good platform engineer knows if you're running 3 and you need to be HA, you better have your pod topology spread constraint set and your anti-affinity rules. And if you're running multiple AZs, your traffic is sky high, and along with your cost. So as soon as you can actually see right here where the migration took place, and we were able to receive the instance savings instantly. You could see it went from about 24 all the way down to about 8, which really surprised us. We weren't aware of how the replication differed from Redis, but we did notice a cost on our bill just from these 8 instances. As I talked about earlier, how here at Akuity, we had a 64 megabytes set for the replication backlog on Redis. So basically, that was 192 megabytes just in memory for the replication. And you can see here when we migrated from Redis to Dragonfly, our utilization was at 9%, went down to a 3%. We obviously have a little bit more work to do on this instance and improve our algorithm for our autoscaler. And you can also see the amount of memory just dramatically decreased. And that's going to be the end of the presentation there. We know there's a lot of controversy about Redis, the number of CVEs in the open source. Obviously, this was opinionated, and we were hoping to save cost and share that with you, and we figured you guys would have a lot of questions. So if anybody has any questions, please step in the center here, and the mic is yours.
I think the first question is, when do you see this being adopted by the Argo CD core thing instead of being something you're kind of hacking into it?
I'm sorry, I didn't hear everything.
Well, so there we go. Mic's on now. Do you see this being adopted by the Argo CD project itself to replace Redis in the open source version there?
I just consider this experimental. I've discussed it with the maintainers and also some community members. Not only the CVEs with Redis, they've had some questionable license changes, and it's been a debate. We're going to look at it. It's definitely an option. It's worth exploring and gathering the community feedback. Argo CD was built modular, so we can plug in Redis. I know there are people where they're actually using managed services, so it's easy to configure any memory data key value store. So yeah, it is possible in the future.
Yep. Thank you.
How much downtime did you experience, or did you experience any downtime between the migration from Redis to Dragonfly?
Yeah, so in terms of downtime, it is negligible almost, because like I said, the cache itself is not a critical component of Argo CD. So even if the cache is down, your Argo CD applications and everything else continue to function. The only issue you might face is with the UI. The data itself is not populated for a few minutes. So as soon as Argo CD reconciles the application, your data automatically pops up. And it's just a few minutes, like I think it's 3 to 5 minutes, I think.
Cool.
Thanks for this talk. We've been looking at Redis alternatives for a while now. I know that there's a post, because I've been looking at some open issues in Argo CD GitHub. There's one open for replacing Redis with Valkey, because Valkey is backed by the Linux Foundation. I was wondering if you've done a compare and contrast, or have any thoughts as to why this opinion may be better than Valkey. That's it.
Yeah, I can probably take that. So Valkey is, as you already know, it's a kind of a Redis fork, right? So at the end of the day, our goal here, like, I'm not going to go into what's right and wrong as such, but from our perspective and the talk's perspective, our goal was to get something better than Redis, and we didn't think Valkey was the solution because it would almost give us the same thing as what Redis gives us today. So we chose Dragonfly, and that's the solution that we're presenting today. And as you can see, there's a bit of savings for sure there. So hopefully that would be option available to you guys to try out, like I had the GitHub repository. But if you're interested in trying out Valkey, that should also be possible in case, if you want.
Thank you.
Just curious, how does Dragonfly decide who's the primary, the source of truth there?
Yeah, so there's a difference between how Redis does it and Dragonfly does it. In case of Redis, it's basically a quorum that the Redis replicas itself decide. So that's the reason we have the three like odd pair situation. But in case of Dragonfly, we have the controller. That controller basically monitors all the Dragonfly clusters and determines which one has to be the primary and which one has to be the secondary and so on.
Thank you. Thank you for your talk, by the way.
So follow up on that. So if the controller goes down, does Dragonfly continue functioning? Leader election stops?
It continues to function as long as the writer instance or the primary instance is up and running. But there's also the scale, like you can also get HA of the actual controller itself. So there is fallbacks that you can have. So if you're running in production, you would probably want to run more than one replicas of the controller itself, which will give you the guarantees.
Got it. And then one more question. Do you consider Dragonfly ready for use in production systems?
We are using it. So I would call it production ready enough.
Cool. Thanks.
And just to add a little bit more, yes, it is production ready. They've gone GA. It's almost 100% compatible with all Redis commands. And in fact, if you exec into the container and look around, it actually uses the Redis CLI.